the recording, and so we can start this meeting. So good morning, good afternoon, good evening. Today is Monday, June 21st, or Tuesday, June 22nd, if you don't live in the United States. Welcome to this instance of the Antrea community meeting. So thanks everyone for joining. And for today in the agenda, we have a presentation and a POC demo for Antrea Multicast support that will be provided by Ruoshen and Lan. So this is the only topic that we have pre-booked in advance in the agenda. So please go ahead with this presentation, Ruoshen and Lan.
Hi. So I will show my screen first. Oh, sorry. Can you guys see the presentation?
Yes.
Yes.
Okay. Okay, let's start. Hi everyone. My name is Chen, and this is my partner Roland. We both from VMware Container team. So today we are going to present you with our design of multicast support on entry. Basically our presentation can be divided into 4 parts. First, we have a basic recap of current multicast protocols and concepts. So in case you have already got some of them. Second, I will talk about some of the CNIs we have investigated about how they implement multicast. Next, we will spend most time discussing our proposed multicast design on entry, and also Roland will give you a POC demo for illustrating what they really looks like on entry. So during my our presentation, please stop us if you have any questions. Okay, let's start. Traditional IP communications allows a host to send packets to a single host. We call it unicast. If it's sent to all hosts, it's broadcast translation. So IP multicast provide a third possibility, allowing a host to send packets to a subset of all host subgroup translation. IP multicast is it's a bandwidth conserving technology that reduces traffic by simultaneously delivering a single stream of information to potential sort of collaborate recipients. Applications that take advantage of multicast include video conferencing and IPTV. So multicast packets are replicated in network at point where paths diverged by routers enabled with PIM and other protocols. We are talking about multicast related protocols. First, I want to talk is IGMP. IGMP is used to dynamically register individual hosts in a multicast group, particularly them. So hosts identify group membership by sending IGMP message to their local multicast router. On the IGMP, routers listen to IGMP messages and periodically send out queries to discover which groups are active and inactive on particular subnet. We also have IP video counterpart called MLD. So MLD v1 is similar to IGMP v2 and MLD v2 It's similar to IGMP-v3. Also, I will talk about DVMRP. It's for routing multicast datagrams to an internet. It's derived from routing information protocol RIP. DVMRP retains the link state database to keep track of written paths to the thought of multicast packages. We have do some investigation of current CNI about multicast support. Most of them, actually, there's already some of them can they support multicast feature, but actually most of them just support multicast feature partially, and we do some investigation to learn how they implement these features. Basically, for OpenShift SDN, it implements multicast as below. So it allocates certain VNID for the created namespace for isolation. VNID here is 24-bit value part of fixed length handler. So if a namespace is annotated to enable multicast OVS tables will be programmed to take actions on them multicast IP. Specifically, the multicast traffic will be broadcast to all the nodes, but for the pods inside the one node, only pod with at least one local pod has joined the multicast group will receive multicast traffic. So you can check with the OVS pipeline I drew here to see how they add tables and flows to implement multicast. And for the OVN Kubernetes, it supports most feature in terms of IP multicast. It supports IPv4, IPv6 multicast with IGMP and MLD snooping. So the implementation is based on OVN. So some concepts are not supporting OVS. It adds default deny or never policy to all IP multicast traffic from all pods, like OpenShift SDN, OVN Kubernetes, and a namespace annotation to enable multicast. So basically, IP multicast traffic is forward only to the pods in the same namespace. Okay. Next, we'll talk about our proposed design on entry. We have two main options. We call it IGMP snooping plus broadcast solution. And the second one, we call it control plan based solution. So each has its advantages and disadvantages. We will summarize it later. And for each option, in-cab, no in-cab, and hybrid mode are discussed. We want to add a new feature gate like multicast true to enable multicast traffic inside the node and the cross node. Default value will be false. So when this feature is enabled, all multicast group will be allowed by OVS data paths for pod-to-pod traffic, but for the internode pod-to-pod multicast, multicast initialization will be different for in-cab and no-in-cab mode, and also the details will be given in the following pages. Some basic setup. When multicast feature gate is enabled, agent in each node will set up basic open flow rule to allow all multicast a green line below. So the flow will allow the multicast traffic to be forwarded as normal, and means multicast data will be flowed into all pods inside the node. And then we enable IGMP snooping OVS. to limit the traffic data in a node to be forwarded to this pod, you can see the command line sample we should add in the green lines. So when it's in cab mode, the agent will install OpenFlow rules to forward multicast traffic to terminal interface entry terminal 0. By default, it will create a flow for other nodes, so the multicast traffic can be broadcast to others. Below us are the sample flow for two nodes via obvious group table. You can see here just two hex numbers prefixed with 0xAB. These are IPs of two nodes in hexadecimal, and the output one is a port number of terminal interface. That is entry terminal 0. So for the node in cab mode, agent will install the multicast email for the multicast multicast traffic between nodes. So the daemon can be mrouted, which is DVMRP implementation for Unix, or PIMD. So this kind of daemons will learn and set up multicast routes between nodes automatically. Lola will talk about in detail later. These tools are not available on Windows, so we may need extra work if we plan to support on Windows. Also, we need to leverage the underlying network to support multicast across node when entry is deployed in node in cab mode. It means the physical or virtual route switches in the underlying network need to support multicast protocols like IGMP, PIM, DVMRP. And today we take a multicast sample. By default, mrouted config cell to add as multicast router on all multicast capable interfaces. And you will broadcast multicast traffic to all nodes external interface. But if there's no pod running as member of multicast group, it will drop and not forward according to entry host gateway and interface status entry gateway 0. And for the multicast group membership management, multicast is dedicated to set up multicast routes and do the traffic transmission decisions. The hybrid mode is a mixture of node in cab and in cab mode. So there's no new rules to be discussed. When the user chooses hybrid mode, both agents will install multicast daemon and create OpenFlow rules for tunneling a node. Okay, we finished the first option. We called it IGMP stooping and the broadcast solution. So any question here? Okay.
So China, actually, I have several comments here. So first, even for in-cab mode, I don't think we should broadcast multicast traffic to every node. Then that is not multicast, right? Or you see other.
Yeah, Jianjun. Actually, we will introduce more in the control plan solution, which will we will involve the controller to make sure that we can do the multicast between different nodes in cab mode. So Ruochen can give the more details later.
I see. Okay, Paul, I'll wait for you. Presentation to
Okay,
ask
thanks.
more questions.
So any other questions? Okay. Now we're focusing on
a dumb question here. How do we configure the multicast address on the pod interface?
how do we configure what? Sorry.
The multicast group address on the pod interface? Like a bunch of pods will be part of a multicast group, right?
Yes.
Yeah. So you mean the port IP?
Yes, the pod interface.
Actually, there's no multicast IP for specific network interface. It's just you can consider it as a logic concept, and as long as you use the IP multicast IP address, you bind it in your process, it will join as a multicast group. So it's actually no need to do anything in the physical or any software interface. Yeah.
Right. A multiple, I mean, group of pods belong to a multicast group, right? Bunch of pods. Right. The pod interface, usually we in any interface, like we enable the multicast on that, and we configure a multicast address, right? So how do we do that for pods? Yes.
And I will show the demo later, and
Okay.
maybe it will answer your question. But
Okay.
indeed, there is a way if you want to allow the interface to be a part of the multicast group, we can do that. But I think it's some process belongs to user perspective instead of our entry part, from my understanding. Yeah.
Oh, okay. Okay. You're saying that application running in the pod can have the multicast.
Yeah.
Okay. Yeah. Okay. Okay. Thanks.
Okay. Thanks for the questions. So now we are focusing on the second solution. We call it control plane based solution. So for the control plane based solution, when multicast feature queue is enabled, agent in each node will set up based open overflow rule to deny all multicast traffic with low priority. So you can see the green line. So it's different from IGM, PCP, and plus broadcast solution. So in that solution, we assign multicast first, but here we drop, we have action to drop the multicast traffic in low priority, and when it's in CAN mode and multicast feature is enabled, agent will install rules to follow the multicast traffic to tunnel interface conditionally. By default, will not create any flow for each node. When there's a pod running a node join the multicast group, controller will get node information and sync it to our agents, and then each agent in the node will set up the flow to allow multicast traffic to target node. So here's a command line below. We have only one IP of node in hexadecimal, which means only in that node we have pods that are subscribing to a multicast group. For the node in Camel, no big difference between IGM just looping plus broadcast solution. Agent will set up multicast daemon for all nodes, and the multicast traffic will be configured by multicast daemon. Also, the hybrid mode, no new rule to be introduced. When user choose hybrid mode, agent will install multicast daemon for each node and create open flow rules for tunnel inside the node. according to the multicast traffic membership. Okay, we have discussed two possible multicast solutions we proposed. Here's the comparison for these two. So for the IGMP looping, the broadcast solution is relatively easier to get implemented, and we don't need to involve controller to do extra calculation. However, it's not a very quote unquote multicast solution, because actually all multicast traffic across node is broadcast. Alternative solution is we can utilize controller to do some calculation first, and that will allow us to overcome the broadcast issue for the first solution. Okay, so next we have Roland to have a POC demo for us.
Hello, sir. I have a question here. Okay, can you go to the last page, the cons and pros comparison? Yeah. My question is, even for option 2, control plane based solution, is the first clause true? No broadcast across node traffic when the traffic mode is no in-cab.
I'm sorry, Roshan, you can go ahead. Sorry, I can answer the question. I think for the no income mode, it's still broadcast if we use the tool Emerald D, but I'm not sure if we use another third party, the PMID. We haven't do the investigation for that tools, but I think at least for now, and for the Emerald D tool, it's broadcast no matter it's the option 1 solution or option 2, they are the same, or broadcast.
Okay.
Yeah.
Thanks.
So for low in-cab mode, actually even for in-cab mode, I think we should also handle the case receiver or sender are outside of the cluster. That's what I heard from customers, some customer requirements. Actually, they want the traffic to be from and can be sent out of the cluster. So we should not only consider overlay in that case. And actually for both no in-cab and for the case, you need to route the traffic outside the cluster in the in-cab mode case. I think originally Antonio and I were looking at a solution called IGMP proxy. I'm not sure you guys know about that one. That one seems a very simple solution, can do IGMP proxy for your host. And then it can send the IGMP message to the underlying network. At least that's our understanding. Then let's assume you are connecting to a physical switch can support IGMP. I think that's pretty good enough, right? Why we need a multicast router on EverNet?
Okay, we haven't do any investigation for the IGMP proxy. Maybe we can do more works on this one. And for now, I think we just use the third party to do the demo. Yeah.
Okay. Okay, I would suggest to do that one.
Okay. Yeah, sure.
Is a configuration or a demo?
It's a demo. You need a demo. Okay. Probably Antonio can add information here. I think Antonio, you did try IGMP proxy, right?
Yeah, it's a daemon that bridges the IGMP traffic essentially between the Antrea gateway 0 interface and the physical interface. And so it relays the IGMP traffic so that the IGMP traffic that goes through the OVS bridge can be sent to the underlay.
Thank you.
Okay, sure. If it's a better option, I think we will do the investigation and make sure that we can pick this one if it's a better one. Yeah.
And Jinjun,
Yeah. Go ahead.
you just said we should consider knowing we should consider in cap, or we shouldn't consider knowing in cap.
I think we should consider in cap. At least that's what we heard from EKS Amazon folks, right? They're saying these customers want multicast, but the AWS underlay level doesn't support multicast, so they are looking at any solution by overlay.
Oh, thank you.
But I feel probably don't need to consider hybrid mode if that is too complex. Of course, it's simple. We can definitely support that. But I mean, if that requires actual work, I personally feel it's not very important to support.
Sure, I think we can set some priority for if there's any implementation started.
Yep.
Okay. Okay, I will start sharing. Oh, sorry. Roshan, I think you need to stop it first.
Sure.
Okay, thanks, Roshan. And I will give the demo about how we can do multicast in Antrea through some manual steps. So we can see how the multicast works in Antrea, and you may learn and understand it better about what we present by Roshan. And as you can see here, this is our demo environment, and there are 3 nodes. The first one, and there's the 0, and we will call this the 0 node. And the first node and the second node, all 3 nodes are actually the work nodes, no matter it's master or not. And by default, I have created the entry by in-cap mode, and the default by default genuine mode tunnel. And you can see here we have 3 agents here. And let's go to here, another window. I will show you that, oh, sorry. Let's go back here. As you can see here, there's 4 parts I already created for the demo, and these 2 are running in their node. And I will show you that how the OpenFlow multicast OpenFlow works when there is added. It can do the multicast. And for the part B and C, and it's running in the node 0, node first, and second node. Okay. Okay, let's go the part first. I will use this 2-part demo, how the multicast traffic inside the node. By default, I will run a server, a multicast server in part A2, and run a client in part A. Let's go back here. Here is some script I will use for demo. And the first, let's go and copy this. Oh, sorry. Okay, here you will see that I start the iPerf with the client mode. This one is the IP address, a multicast IP address. It's one of the class D IP. And okay, back to here. Okay, I will start part A2 in the same node. You will see that even we start this and bind the multicast address, there's no connection between these 2 process. And let's go back to the 0 node, and I will go and execute. Actually, this script it will actually run some command inside the agent Antrea agent in the 0 node. Let's edit the default workflow. to the table 0. This one will actually allow all the multicast in our OS bridge. When the action is normal, it means that any broadcast traffic will be treated like normal traffic. It looks like there's no open flow inside this bridge. And we will do more setting to make sure that there is no broadcast flood. Okay, let's go back to the, oh, here you can see it's still not working, but I think I need to restart the, oh, it doesn't work. Let me restart it. There's some problem here. Oh, sorry. Oh, okay, let's go back to show the, okay, the action is good. And let's go back to the, sometimes happen. Let's let me exist this and also exist. I believe it's caused by the tree which I used to, I set up IPsec for this. So let me delete the tree first. Okay, and also delete the pod. Okay, it will take a little longer. Let me go to here and create an entry first. Okay, here. Let's see the pod. Make sure the pod is running. Great, the entry is back again. And the pod is still terminating. And let me go back to the, okay, let me copy this script and set the entry agent in 0 to allow the multicast flow. Sorry. Okay, here, let's dump the flow first to double check the flow. You will see that this flow with a high priority, it will handle first if there's any multicast traffic. Okay, let's go back here. Okay, let's create the demo. Great. Okay, here's some parts we will use for demo, and let's go back here. This client is another server. And for this one, let's start the Multicast server first. Okay, it's running. And second, let's start the client. Oh, you will see that it's connected now. Before the, you will see it's first, there's no connection because we didn't allow the multicast traffic. Now we can see they are connected now inside a pod, inside a node. Okay, let me stop it here. Oh, I think I shouldn't stop it. Okay, for the inter-node multicast traffic, I will use another 2-pod to make sure that there is no multicast traffic at the very beginning by default. this is a part B and running in the first node, and here's another part running another the second node, which I showed at the beginning. Okay, let me also start the broadcast server first. Sorry, multicast server first. You will see that, okay, I need to increase TTL once you want this traffic to be sent out of the node, you need to increase it. Okay, here, let's start it. Great, you will see that because we already have the flow allowed inside a node, so it can connect it by now. But for the intra node, we cannot get any connection here. You will see that no traffic, no connected information here. Let's go back to the, okay, by Geneve, I will add a group first in this agent one, entry agent in the 0 node. Okay, added a group first. This group, it actually means that once the broadcast, sorry, this is just a group, which means there are some traffic. If you want to send this group, it will do such action to load the IP address to the tunnel IPv4 destination first for these two remote nodes. This actually the IP of the two remote nodes, the first and the second node. And then we don't need to dump the groups. We just add the flow. We just add the flow to allow the traffic to be sent out to any remote node. It has a highest priority here, so we can have the action group 7, which means it will send to the tunnel interface and also do the normal action to allow the multicast traffic inside the pod. Okay. For now, you will see that there is still no connection because we haven't set any configuration to allow the multicast in the first node and second node. So let me go back here. Let me go and do agent 1, so we can execute some command in the entry agent 1, and we will just simplify the open flow to allow all the multicast as normal here. And another one is agent 2. It's actually the agent in the second node. We do the same action. Okay, let's go back here. Great. You will see that there is a connection between those all 4 pods. These two are cross nodes, and these 2 pods are in one node. Okay, let me go back here. Let's go to for in-cab mode. I think that's all for the in-cab mode, and I will go to show you that no in-cab mode. So I need to delete the entry first. Okay, it will take a few seconds. Okay, cool. Let me create. Oh, let me make sure that it's clean first. Okay, good. Okay, let's create. Oh, sorry, I haven't changed the mode. I need to change the mode first. Here, the traffic modes, I need to change it to no in-cab. Okay, let's go back and create as before. Okay, here the 3 agents here. Let's wait a few seconds. And still there are 4 parts for demo. And let me go to the, so the part has been existed. Let me go to the agent 0 first in the 0 node. we have to do, we just need to simply added the normal flow to allow the traffic between inside node, and the multicast daemon will do the job across nodes. Okay. For no in-cab mode, we just need to add the normal action here. So let me add the normal action and agent 1 and agent 2 here. Let me add the same flow. So you will see that there are all normal actions for the multicast traffic inside node, and for the traffic across the node, you will see that I already installed the third party, the Emerald D. Let me show you that. Oh, sorry. It's a little slow. Why it doesn't input all the, sorry. Okay, you will see that it's the status. Let me clean all. Interesting, it doesn't work for multiple input. Okay, let me copy this. Oh, I think the terminal is, I need to reconnect it. Sorry, let me, this node 1, okay, let's connect node 2. Okay, oh, sorry. Okay, there are 3 nodes here, and let me show you the status of the Emerald D. Okay, it's actually all running and healthy. So let me go back. By default, this daemon will be responsible to set up any multicast route if there's any multicast IGMP message inside a node. For example, one pod binding the multicast address and trying to receive any multicast traffic for the IP group. And okay, since we confirmed that this daemon is active and running, let's go back to the, okay, great. It's actually is connected, as you can see that from multi, let me rerun it again. Okay. Okay, you can see here, it's all connected. Even cross the node with no in-cap, and inside a node, there are part A and part A2. They're also connected with the multicast traffic. And you will see that, you can see that IP multicast route, route here. And all 3 have the similar, similar information. You will see that in 0, the first and second node, they all have Emerald being added by this daemon. And there are also more information if you like to use the control command line provided by this daemon. And there are some multicast forward caching table. And if there's no multicast inside the node, there will be no information or any record in this table. Okay, I think that's all the demo for in-cap and no in-cap. Let me know if you have any question, and I will stop the demo here.
Lan, could you switch to the third terminal that show the IP? I saw that the first node and the second node, the IP in that node is the node IP. The connected IP is node IP instead of the port IP. Is it because the traffic is netted by those nodes? You see the.
You mean the first one?
No. I mean the two connection on the right side.
Yes. I think so. Yeah.
So if we disable NAT, we should get the port IP.
I actually didn't try this. Maybe I can try that to verify how it will work.
Okay. So is this 26.12 is the IP of the zero node?
Yeah, correct.
Okay, thank you.
Okay, thanks. Are there any more questions? Okay, let me stop here. Okay, thanks all. There our presentation and demo.
Thanks, Lan and Rochen. That was a very informative presentation. You presented quite a lot of options, and that's great. My opinion, I also share with Jianjun the concern that broadcast across nodes is it's not probably what users will be looking from a multicast solution. But on the other hand, I also appreciate the fact that we want to be sort of self-sufficient with OpenShift and not starting installing many open source components. So I wonder if in your investigation, you believe that there is something else that OpenVSwitch can do, or whether the flow settings that you have provided is everything that OpenVSwitch can do for multicast. And you also mentioned the control plane solution. Yes, my second question is that you mentioned the control plane solution, and did you do any experiment to verify whether that can actually allow us to save useless broadcasts?
Sorry, your first question is about the broadcast concern, right?
Yes, but technically both are about let's say the solution without mRouteD, and the first solution. The first question is whether there is anything else that we can do in OpenVSwitch, even if we had to implement something new in OpenVSwitch. And the second question will be, I would like just to know more about the control plane solution that Rochen mentioned.
For the first one, actually, I think OVS only supports IGMP snooping, and for cross nodes, we can do the multicast for in-cab mode, but for no in-cab mode, I don't think OVS by default can provide multicast support. If you say that if we do some OVS implementation, I don't know if we can do that to support it. Maybe we can do more investigation for that part. And for the second one, can you repeat your question? Sorry.
Yes, I would just like to understand a little bit more about the control plane solution that Rochen mentioned to prevent broadcast, to prevent multicast traffic to go and broadcast across nodes.
Yeah, sure. For control plane based, it's actually more about the in-cab mode. For no in-cab mode, actually there are no difference. We are still, at least for our current demo, we are still using the third party, and it's actually do the same thing to broadcast the traffic to all nodes. And for in-cab mode, because we can involve the control plane, we can let the controller to notify or agent to grab the information from the controller to know that which node have the multicast group member. so we can reduce the broadcast and using just a multicast across the nodes.
Okay, and so I'm sorry, but I have two more questions. So let's start still on this topic. You say that the node can know when the controller can know on which node there is a pod, there are given multicast members. But if I'm not mistaken, we don't know if a pod is a multicast member until they open a multicast connection, right? Because when you start a pod, the only thing that you know is that just whether you want to enable multicast or not on that pod. You don't have yet membership information.
Oh, yes. Actually, in our design, we assume that the user will do some annotation like this deployment has multicast application running inside the deployment. So which means we can find out which pod are running in the node. That's our proposed design. You're right. If there is no extra information, we cannot know that part.
Okay. Yeah, thanks for the clarification. And finally, final question. I swear this is my last question.
Sure.
Is it for the no-in-cap solution and clearly the hybrid solution, is it possible to do without mRouteD or any other third-party multicast routers? Or in my understanding, we do need that third-party component, right?
Yes, I think even the IGMP proxy mentioned by Jianjun, he also said it's still a daemon. So I guess we cannot do that without it. Except we want to implement a multicast protocol by ourselves. I don't think that's an option. Yeah.
No. And so as a follow-up on this one is instead, could we use mRouteD or IGMP proxy in in-cap mode? Sorry, this is just my ignorance, and I wanted to understand if this would be possible to use. I mean, the same demo that you've done with mRouteD, but run it in in-cap mode.
For just for the in-cap mode.
Yes.
I don't think so. For in-cap mode, I think we assume that the data go through the tunnel interface. Looks like it will not go through the external interface by default. I'm not sure about these details, but maybe I will. I think I can verify that, but I doubt it. It can work on.
No. I know that the traffic obviously doesn't go to the external interface. I was wondering if there is if there could be a solution for running having mRouteD run intercept traffic before it goes into the tunnel, but probably that's not possible. That would require. I don't think there is a way for doing that, honestly. So yeah, that was probably a little bit of a dumb question. So yeah, thanks for all your answers.
Salvatore, I think you mean you want to run this mRouter protocol in the overlay network. I guess maybe that is possible. I'm not saying we should do it. I think technically maybe it's possible. We bind this mRouteD. I don't really know that much, but assuming it can bind to the interface, maybe we can bind it to the Antrea TW0, and then we run the protocol inside the overlay network.
Yeah, that's pretty much what I meant. I don't know what is the best way of doing it, but I'm thinking that if we need to use mRouteD, then maybe we might want to use it both for in-cap and no in-cap, but that would be just like an alternative, not really super important at this stage. So yeah, thanks. I have exhausted all my questions. Sorry. Every time that I see an interesting presentation, I end up with a lot of questions. So I apologize for using a lot of time. And we still have 3 minutes into the meeting. Is there any other question, comment, observation on the design?
Yeah, since we talked about, I just want to mention. Earlier, I considered another way. So very similar to IGMP proxy, but I was thinking in theory we can also do. Let me see. I know in the Linux TCP/IP stack. I'm not really sure it's Linux or BSD. At least in BSD, probably I should say that way. In BSD TCP stack, you have a way to use the socket API. I believe in Linux too, you have a way to use socket API to join multicast group. So originally, I consider a solution that we do IGMP looping in open switch, and then our daemon called the socket API to join the multicast group for the local groups on the node IP interface. So I believe in that case, the node can also do IGMP protocol to the underlying network. Again, I'm not really suggesting we should go that way. At least later, since Antonio and I look at the IGMP proxy, I think that one sounds like a simpler solution. But I just want to mention for you guys, just for reference purpose. I think there's indeed another solution we can just do IGMP using socket API without any third-party code.
Sure. I will check that. Thanks.
Yeah, we can also check offline if you want to know more information.
Sure, thanks.
All right. Any other question? Perfect. So before concluding this meeting, Lan and Roshan, at this stage, what do you believe would be the next steps in your investigation, design, and implementation work?
Sorry.
What are the next steps?
Maybe we'll look at IGMP proxy, Dendrin mentioned, and see if there's a simpler approach using IGMP proxy. Maybe we'll discuss offline.
Perfect. Out of curiosity, do we have already an issue on GitHub to track multicast efforts?
Yes, we have an issue. The number is 2251.
Okay, thanks. So I guess we can also use that data tracker for additional conversation. Perfect. Okay. Unfortunately, we are top of the hour now. And is there any final question, comment, anything else to report for today's meeting? Perfect. So I would like to thank again Roshan and Lan for the nice presentation and proof of concept for Multicast in Antrea. And I would like to thank everyone for attending this meeting and wish all the attendees a good evening, a good morning, or a good afternoon.
Bye.
Bye.